What if humanity's best shot at surviving beyond Earth isn't Mars? What if the real answer is a frozen world, orbiting a planet so magnetically violent it could fry your nervous system before you even touch down? And what if, buried beneath 95 miles of solid ice on that very world, there's an ocean holding more water than every lake, river, and sea on our entire planet combined? Here's what most people get completely wrong about space colonization. We've been so fixated on the red planet that we've barely glanced at what might be the most resource-rich moon in the solar system. A moon bigger than Mercury. A moon with its own magnetic field. A moon that might already contain the chemical building blocks of life. This is Ganymede, Jupiter's crown jewel. Its surface stretches across roughly 33 million square miles, meaning you could fit the entire United States inside it nearly 9 times. If it orbited the Sun instead of Jupiter, we'd call it a planet without hesitation. But size isn't even the interesting part. Peel back the layers, and Ganymede looks almost Earth-like. A liquid iron core churns at its center, generating the only known magnetic field of any moon in the solar system. Around that sits a rocky mantle, and above that, ice and water extending roughly 450 miles deep. Buried beneath that frozen crust, scientists believe, is a saltwater ocean about 60 miles thick, 10 times deeper than Earth's oceans, likely holding more liquid water than our entire planet's surface. NASA confirmed the strongest evidence in 2015 when Hubble tracked how Ganymede's auroras wobbled against Jupiter's magnetic field. The ocean's conductivity was dampening the motion. The water was betraying itself from the inside. I call this Ganymede's defining advantage, the ice vault, because that ocean isn't just water. It's breathable oxygen when you split it. It's drinkable supply when you desalinate it. It's rocket fuel when you crack it into hydrogen and oxygen. It's the single most valuable resource imaginable when you're building a civilization 500 million miles from home. But most people stop here. They hear water and think the problem is solved. Actually, the water might be the easiest part. Jupiter is not a friendly neighbor. Its magnetic field is roughly 20,000 times stronger than Earth's, capturing charged particles and accelerating them into radiation belts so fierce that ESA has called Jupiter the Mount Everest of the solar system in terms of radiation. On Europa, an unshielded human would die within hours. On Io, you'd absorb 3,600 rem per day, when 500 rem over a few days is typically fatal. Ganymede is further out, and its magnetic field carves a small protective bubble. Think of it like a snow globe inside a hurricane. It helps. But Ganymede's surface still receives about 8 rem daily, 333 times your annual exposure on Earth. 2 months unshielded, and you're looking at severe illness or death. So, where exactly do you put a colony? This is where something I think of as the ice shell protocol comes in. Instead of building on the surface and fighting radiation with imported shielding, you go down. You burrow into the ice. Even a few dozen feet of solid water ice provides extraordinary radiation protection. Build habitats within the upper crust, and Jupiter's rage becomes almost irrelevant. The ice insulates against the cold, it blocks the radiation, and it surrounds you with the very resource you need most. Pressurized chambers and ice caverns, connected by tunnels, with electrolysis units splitting wall ice into oxygen and fuel. Grow lights feeding hydroponic farms. Nuclear reactors keeping things livable while everything outside sits at nearly 300 degrees below 0 Fahrenheit. Here's what nobody talks about, though. Ganymede has another advantage that rarely enters the colonization conversation. Its surface gravity, just 14.6% of Earth's, means launching rockets requires dramatically less fuel. Escape velocity is only about 6,100 miles per hour compared to Earth's 25,000. Ganymede could function as a refueling depot, a launch platform, a staging base for missions to Saturn, Uranus, Neptune, and the Kuiper Belt. If humanity ever wants to become truly interplanetary, we need forward operating bases. And Ganymede, sitting in the gravitational neighborhood of the largest planet in our system, surrounded by over 100 moons, rich in water and minerals, is arguably one of the best candidate we've identified. Now, the hard part. Getting there. Jupiter orbits at roughly 484 million miles from the Sun. ESA's JUICE spacecraft, launched in April 2023 and currently en route, won't orbit Ganymede until December 2034. 11 years. And that's just instruments, not people. A crewed mission would need food, oxygen, medical supplies, spare parts, and enough shielding to survive years in deep space, plus months threading Jupiter's radiation belts. Communication delays of 35 to 50 minutes each way mean every emergency gets handled alone. Yet there's a reason this might be worth it, and it has nothing to do with convenience. In February 2026, researchers published findings showing that complex organic molecules, the chemical precursors to life, were likely built into Jupiter's moons during their formation 4 billion years ago. Not simple compounds, the kind that, given water and energy, can lead to amino acids and nucleotides. Jupiter's moons may not have formed as chemically sterile worlds. Ganymede has a liquid saltwater ocean, internal heat from tidal forces, and radioactive decay, a magnetic field, and now evidence that organic chemistry may have been present from the beginning. We're not saying there's life in that ocean, but the ingredients are there. The recipe book is open, and that raises the contamination paradox. The very water that makes Ganymede attractive for colonization could harbor the most important biological discovery in human history. Use it carelessly, and we might destroy alien life before we know it exists. Protect it too zealously, and we never establish the colony. That 95-mile ice barrier works both ways. It hides the ocean from us, and it keeps us from accidentally poisoning it. So what does a Ganymede colony actually look like? Subsurface habitats carved into ice, compact nuclear reactors, water extracted from surrounding walls, agricultural bays under artificial light, a shielded surface spaceport launching missions across the outer solar system. And somewhere beneath all of it, an ocean larger than anything on Earth, dark and silent, holding secrets 4 billion years in the making. Ganymede isn't the easy choice. Mars is closer, the Moon is next door, but neither offers a limitless water supply, a magnetic shield, a surface larger than Mercury, a strategic gateway to the outer solar system, and an ancient ocean that could be important for astrobiology. The real question isn't whether we could colonize Ganymede. The engineering says we can. The real question is whether we're brave enough to drill into that ice and face whatever is waiting on the other side. Would you choose the ice vault? Tell me in the comments. And as always, keep looking up.